Well, hello again. We are moving on in our discussion of differential calculus. We are going to talk about normals to curves. All right, this is lesson 12.6, so let's get started. First of all, in the last lesson, we talked about how to find the equation of a tangent line to any point on the curve. Well, now we're talking about the normal line, and what the normal line is it's a line that's going to pass through the exact same point that the tangent line does, but it's going to be perpendicular to the tangent line. So as far as steps go, there's really only one thing that we need to change, and that's the slope. The point is going to be common to both lines. The only thing that's different is going to be the slope of those lines. So again, I call the x-coordinate x1 just like before. I plug that into f of x to get the y value if I didn't have it before. I still find the derivative, but that's not my slope anymore. Once I plug x1 into the derivative, I'm going to take the negative reciprocal or the opposite reciprocal of that, and that's going to get me a perpendicular slope. I'm going to call that gradient or that slope. I'm going to call that m. I plug those in and it will be in point gradient form, and I can go on from there. So again, let's do a couple of examples. First of all, I want to find the equation of the normal line to the exact same curve as the last lesson, but at x equals 1. So I'm going to let x1 equal 1. I'm going to plug that into the function, and I get 0. So the y-coordinate at that point is 0. Taking the derivative, it's the same as it was before, but now I'm plugging in 1 for my x's, and I get negative 4. Now negative 4 would be the slope of the tangent line, so I want the slope of the normal line, which is perpendicular. The opposite reciprocal of negative 4 would be positive 1/4. So that's the slope of the normal line. I'm going to plug in my 1, my 0, and my 1/4 into the point gradient form, and that's the line that I will get. And you can kind of see that that line is perpendicular to the curve at that point. Okay, one last example. We are going to see where does the normal line at x equals 0 touch the x-axis. So the same point as in the last lesson, but now I'm looking for where the normal line touches the x-axis instead of the tangent line. If I plug 0 into my function, I get a y value of 3. My derivative is still the same. It's 3x squared minus 6x minus 1. And when I plug 0 into that, I get negative 1. So negative 1 would be the slope of the tangent line, but I need to take the opposite reciprocal of that to get the slope of the normal line, and that is positive 1. So I'm going to use x equals 0, y equals 3, and m equals 1. Plug those into my point gradient form, and I get y minus 3 equals 1 times x minus 0. All right, now I want to know where does that touch the x-axis. So let's look at that. If I want to know where it touches the x-axis, I'm just going to set y equal to 0. So I get 0 minus 3 equals 1 times x minus 0. Well, the left side simplifies to negative 3. The right side simplifies to 1x, or just x. So it is going to cross at x equals negative 3. All right, so similar to before, we only changed that one step to make it a normal line instead of a tangent line. But if you have any questions, please let me know, and I will see you tomorrow.